Welcome, ladies and gentlemen, to your MN1 notes. This is your first note guide in geometry class, and what we do is we number our notes at the top left-hand corner, kind of like a book. We're numbering them 1, 2, 3, 4, and so on. This is your very first note guide, so we are going to number it MN1. So MN1, we're going to find an equation of line through 2 points. This is section 3.5 in your textbook, and it is definitely a review from last year in algebra, but it's a good review. It's something that we're going to use periodically throughout the year. It says, example 1, find the equation of the line between -2, 4 and -3, 0. There's really a three-step process here, folks. You're going to find the slope between those 2 points, then you're going to find the y-intercept, and then you're going to put those pieces together. So to find the slope, we use the slope formula, which is y2 minus y1 over x2 minus x1. Now, which one you decide is your first and second point really doesn't matter. I'm going to say this is my first point, this is my second point. So if that's my second point, that's going to be what I use first. So since it's x and y, I'm going to put my y value 0 minus my other y value over here, 4. So again, this is my second point and my first point. And really, I can't stress it enough, it does not matter which one you put first. But once you do decide which one you put first, you need to be consistent with it. So 0 minus 4, and then it's going to be -3, which is my second point x-coordinate, -3, minus a -2. So again, not to get too fancy here, I'm just letting you know I just am taking this y value minus this y value to find the difference, and I'm taking this x value, since I chose that 0 first, I have to use this one next, -3 minus a -2. And that is going to give me the difference in my y over my difference in my x, which is slope. So 0 minus 4 is -4. -3 minus -2. Now that minus negative, you can think of it as addition. So we end up with -1. We have -4 minus -4 divided by -1, which is a slope of +4. So again, over here with the number operation, 0 minus 4 is -4. -3 right here, minus -2 is like saying +2, and that gives me -1. Divide it out and you end up with a slope of 4. Now, step 1 typically is not the issue for students. Step 2 is where people sometimes get stuck. Well, actually, they get stuck everywhere, but I'm just saying this is a place where it gets a little confusing for a chunk of students. I'm just going to say the easiest way to think about what we're doing next is to start with the general form of the slope-intercept equation. So y equals mx plus b is just a generic form of that. What we need to do is we need to find the slope and we need to find the y-intercept to have the equation of the line that goes through those 2 points, -2, 4 and -3, 0. Well, we found the slope already. That's the great thing. So I'm going to put that in. What we haven't found, or what we need to find, is this, which is the y-intercept. Now, to find the y-intercept, you're going to need to fill in a value for y and a value for x in order to solve for b. So this is what we're trying to solve for, b right here, the y-intercept. Now, you have 2 xy coordinate points up here. Remember this up here? I'm going to erase this. You have an xy here. This is an xy point. This is an xy point. You can choose either one of those to put in for x and y down here. This is x here, y here. So I'm going to choose, I'm just looking at them, and I'm going to decide on the second one because it kind of looks a little bit easier even though we have a negative. Now be careful, people like to put in the x in this y spot, so you want to make sure that you're putting the y value in for y, which is 0. So we're putting 0 in for y equals 4 times, and instead of x, it's going to be -3 plus b. Okay, and as always, I seem to run out of space, so I'm going to rewrite this up here. So I have 0 equals 4 times -3 plus b. I'm just rewriting it. Now to solve for b, I have to first combine these two, or multiply those. 4 times negative 3 is negative 12 plus b. And then to solve for b, you're going to add 12 to both sides of the equation, or equal sign, and you end up with b is equal to 12. So we have our b value, which is our y-intercept, where it hits the y-axis. We have our slope, which is 4, which is the steepness of your line. And now at the very end here, we're just going to put those pieces together. So it's going to be y equals the slope, 4x, plus the y-intercept. So y equals 4x plus 12. Now, this again is a review, but you might be extremely rusty or last year may have had trouble with this concept. So let's do it again here in letter B. It says find the equational line between those 2 points. The nice thing is they're positive points, so I like that. So step 1 is to find the slope. Oops, I don't need an arrow, do I? I need an equal sign. Equals. So y2 minus y1 over x2 minus x1. Again, I'm going to just use this as my second point, or the beginning point, I guess. So my y2, my y, and again, these are xy coordinate points. So I'm going to say 5 minus, again, this is an xy point over here. So 5 minus 1, I want to find the difference in my y's, and then I want to find the difference in my x's. Now again, I chose 5 for my y to start with, so I needed to start with 4 over here for my x. So I have 5 minus 1, the difference in my y's, 4 minus 3, the difference in my x's, and that's, oops, oh, I just all of a sudden lost my smartboard here, is equal to 4 over 1, which is going to give me a slope of 4. Now, at this point, you might be starting to say, all the lines that Ms. Bakken uses has a slope of 4. But that's not necessarily the case. In this case, it is, and there's a reason for that we'll talk about very shortly. But let's find the y-intercept equals mx plus b. It almost gives the impression that it's going to be the same line. So, again, what we want to do when we find the y-intercept is put in what we know. We know the slope is 4. And we do know 2 xy points. And I'm going to choose this one this time because it's little smaller numbers. So the y value is 1. Now be careful not to put 3 in. 3 is the x for this coordinate point. So 1 equals 4 times, instead of x, it's going to be 3 plus b. So I have 1 equals 12 plus b. I'm going to bring this up here because I'm running out of space. I'm going to subtract 12 from both sides to solve for b, my y-intercept. This here is negative 11 equals, this is gone, and that's b. So now we have our 2 pieces for our equation. So again, the general form is y equals mx plus b. We found m, the slope up here, and we found b right here. So we can now put those together for step 3, which is y equals 4x minus 11. Now if you look at this, we've got an equation up here, 4x plus 12. We have an equation down here, 4x minus 11. They're obviously not the same line because they start at different spots. The y-intercepts are our starting point when you graph using slope-intercept form. So here it has x at the bottom. What can you conclude about the graphs without actually graphing by comparing just the equations? Now again, the slope or the steepness of 4, so we have a slope here of 4 up here, 4x plus 12, so 4 up there, and we have a slope here of 4. So the steepness is the same, so you can say steepness, or you can call it slope, is the same. Y-intercepts, different. So what can we conclude? You know what, if you were to graph these, and I'm going to just sketch it in a moment, actually, after I Okay, so we have the same slope and two different y-intercepts. So what this is going to give me is parallel lines. And you know what? I did this without even thinking. I used the symbol for parallel. This is the symbol for parallel. Of course, you can write it out, which is P-A-R, parallel. Ooh, those are two L's right there. Parallel lines. And really, folks, it's kind of nice because what you can do is you can just graph these super fast or do a sketch almost. Like this one over here. I'll do this one in blue. Negative 11 on the y-axis, let's say, is about right here. Negative 11. And we would go up 1, 2, 3, 4, and over 1. And again, this is just a sketch, of course. But there's that line. And I'll do this other line, which I can't remember what the equation is. It's y equals 4x plus 12. So I'm going to do y equals 4x plus 12 in green, and that the y-intercept is up here, let's say at 12. I'm going to go up 4 and over 1. And again, these are sketches, not to scale, but it's just to illustrate what I'm referring to as parallel lines. So different y-intercepts, but same slope will give you parallel lines. Okay, so that first example, the goal is to understand how to find the slope, find the y-intercept of a line that given 2 points, and then put those pieces of information together. Now there are two special lines, or two cases of special lines that kind of, I don't know, give students a little bit of a run for their money. So I'm going to go through those right now just kind of quick. It says write the equation of the line that goes through that point and that point. And again, step 1 is find the slope. So let's find the slope. Okay, we have y2 minus y1 over x2 minus x1. And then from there, I'm going to take that second point and use that as my second point. So 12 minus 3 over negative 5 minus a negative 5. The top is going to give me 9. And the bottom, we have negative 5 minus a negative. This is just like saying plus in here. That's going to give me 0. That, my fine young ladies and gents, is a problem. Because if you have 0 in the denominator, that is a big flag. That means you have an undefined slope, which means that it doesn't exist. At that point, if something funky like that happens, what you would want to do is throw a sketch up, because you're going to see really quick why it's undefined. If you go negative 5, let's say this is negative 5 here, 1, 2, 3 is right here. There's negative 5, 3, oops, kind of. And negative 5, 12, let's just say this is 12 here, just for time's sake. So negative 5, 12. You notice these points are right on top of each other. That means that they're not a function. It is a line, but it is the one example of a non-function because it does not pass the vertical line test. And here's the thing. That means you have a vertical line. Notice where the y-intercept is. There isn't one. So find the y-intercept. Boo, there is none. It doesn't happen. You can't say 0, because if you say 0, then you're saying it's crossing the y-axis at 0 right here, which it clearly isn't. So in this case, you have an undefined slope. Doesn't exist because it's up and down. There's no steepness. It's just up and down. And there is no y-intercept. So what does the equation look like? Way down here. Well, let's put it this way. Y equals mx plus b is what we usually do. But in this case, that's why it's called special, it crosses the x-axis here at negative 5. So this is a time, I'm going to get you guys sick by going up and down this. You don't use this form. It's just going to be x equals negative 5, because the x value, no matter what, is negative 5, regardless of the y coordinate. This, ladies and gents, is the equation. That's it. And so if you have a special line that's vertical, no undefined slope, no y-intercept, that is going to be the way the equation looks. Okay, and that is weird, I know, which is why I'm giving you an example in your notes so you can reference back to it. This is the other weird one. I'm going to find the slope, y sub 2, oops, m equals y sub 2 minus y sub 1 over x2 minus x1. So we have negative 7, this is my y, minus a negative 7 over 0 minus 6. Now this is a little different. Here, instead of having a 0 in the denominator, we actually end up with a 0 in the numerator. And if you have a 0 in the numerator, that's okay, but it's going to give you a slope of 0. So my slope here is 0. So if you have a 0 in the numerator, that's just going to be 0, because 0 divided by negative 6 is 0, kind of like 0 times negative 6 is 0. Over here on the left side, though, that's a 0 in the denominator. That's a problem. Okay, so again, if you get a 0 in either the numerator or denominator, my hint to you is to sketch a graph of the 2 points. So the 2 points are 6. I'm going to just say 6, negative 7 right here, just to give me an idea of what it looks like. And then 0, negative 7 is right here. And this line is not vertical, but it's horizontal. And I'm actually going to come over here and make sure that you have that written down over here. This is a vertical, how about I spell it right? Vertical line, because it goes up and down. This is a horizontal line, because it goes horizontally. Now, if you have a situation like this, where it's horizontal line and a slope of 0, you can start with this y equals mx plus b equation. And here's the thing, you know the slope is 0. We found that up above. Y equals 0x plus b. 0 times anything is just 0, so this goes away. And y equals where it hits the y-axis. If you look, it's hitting this y-axis right here. So this is the, oops, my machine again kind of is, this is the x-axis, this is the y. It's hitting the y-axis right here at negative 7. So if I, again, I put 0 in for my slope, and my y-intercept is negative 7 right here, this is what my equation is going to look like. So, oops, and actually, I totally messed that up, didn't I? I'm going to erase this, my apologies. Because the second point is finding the y-intercept, right? If you look up there, the y-intercept is negative 7. That's what I should have put in your notes. My apologies, sorry you guys. I jumped the gun. Down here, way down here, I gave way too much space. Is y equals 0x minus 7, or plus a negative 7. This is 0, so the equation is y equals negative 7. So this is an equation of a line for horizontal. This is an equation of a line for vertical. And these give kids a hard time. So those you might want to reference or remember where they are in your note guide. You'll be looking back at them periodically. When you come in tomorrow, we'll take any questions you have. Thanks for tuning in.